Hello, friends. We know that the mankind has been trying very hard to set up their moon base, and this is a stepping stone because after the moon base is set up, then we would like to go to Mars and then repeat the whole process again. However, it is easier said than done. And why? Because if humans have to live long term on the surface of the moon, they would need shelter, air, food. So before they start, we start to send our ambassadors to moon, we need to set up their house and atmosphere and food, etc. So even before we start doing that, we have to start sending the AI robots who will then construct the habitat for humans. Lot of research is going on in this area, and while we can send the AI, we can send the robots through our spaceships. However, where is the building material? Building material is a big question, because if we have to send the building material from Earth, it's going to be very, very expensive. It's going to be very costly, and also it will not be practical, because to send so much building material from Earth like concrete, cement etc. will not be a viable solution. So there is a lot of research going on in terms of how do we utilize the local material which is available, and in order to basically convert the local moon soil or moon regolith into a building material, and also use it for farming, and probably use it for creating atmosphere in a closed environment. We need to basically do a lot of research in terms of to find out whether the local material is suitable for construction. So scientists have been studying this right from the day when the Neil Armstrong brought a lot of samples from the surface of the moon. A lot of research has been going on, and therefore now we have a very solid plan. And in order to use the moon soil or moon regolith, as we call it, let me explain what is so special in that moon soil. First of all, the moon was formed after the Earth was formed. I mean, that is a general understanding of how the moon was formed. Basically, a giant planet collided with the early Earth. The early Earth got disintegrated because of this collision, and including that giant planet. Then the current Earth is basically a mixture of the that planet as well as the earlier Earth, and that is a time when the moon and the Earth was formed. So a lot of material was flung into space, then accumulated and created a round body like moon around the Earth. So therefore, initially when the moon was formed, there was a lot of heated material deposited on the surface. It was quite hot, and there was everything is made of lava. Because of the collision, the heat was generated, and that landed on the surface of the moon, just like the Earth. So when the moon was formed, there was a flow. That means the liquid material was flowing like a lava flow. And post the formation of the moon, there was the early cosmic bombardment of various objects like asteroids and comets. And because of that, the early moon took certain shape and sizes. So when we look at the moon today, when we look up in the sky, what we see? We see the scarred surface. Now it is the scarred surface because there are flows on this side. From the side that we see from the Earth, which is, we call it near side, there's a lot of lava flows, and that creates valleys, mountains, etc. However, on the far side, the side which is not visible from Earth, there are a lot of craters. There are craters within craters. That means there is a evidence of the bombardment which happened later on, when the moon was still forming and cooling off. So because of this bombardment which is coming from the other side, the internal composition of the moon changed slightly. Usually what happens is that the heavier material sink into the center, into the core, and the lighter material basically float above, and that creates the crust, which is a similar process on Earth also. We have a lighter crust, and the internal, which is core and mantle on Earth are heavier than the material of which the continents are formed. That is why continents are up there in the as part of the crust. And most of the iron and nickel, which are heavier, have sunken down into the core. So similarly, this was the case. However, it changed because moon was much smaller as compared to Earth, and a lot of these material actually started creating a new type of geology on the surface of the moon, which actually ensured that a lot of this heavier material like titanium and other heavier material which are still found on the surface of the moon. And the regolith that we see today on the surface of the moon is a very fine grounded powder types material, and it is very rich in titanium and also other material like iron, etc. So on the surface we got a lot of these material on moon. Otherwise on Earth we have to dig deep down and create mines, and then basically mine the iron ore and titanium, etc., and then use it for our purpose. So on the moon it is available, and it is completely mixed with this powdery structure which we call regolith. So how we can use it? So scientists have actually found that using the chemical processes, using just the soil, you can actually get water, oxygen and hydrogen out from the soil itself. Now hydrogen can be used as a fuel for our future mission. We can use it, we can convert into biohydrogen, or we can use hydrogen to create methane, mix it with the bad air with carbon dioxide and human waste, and create some sort of methane, which we can further use it as a fuel to fire up our rocket or various other requirement. And otherwise hydrogen is highly combustible, we can use directly. So we can get the hydrogen out from the regolith directly, we can get the oxygen out, and we can also get water out. So these three basic ingredients we can create from the soil of the moon. So once we create our habitat, we can use the normal soil to create atmosphere for comfortable living. For the future astronauts, we can use hydrogen to create fuel. So with fuel we can create rocket fuel, we can also create heating, cooling, all kinds of things are possible if we have the fuel. So we have two basic needs taken care. Now there is a lot of research going on in terms of creating food or growing cultivation or growing some vegetables on the surface of the moon, because carrying food also is quite difficult from Earth. So if we are able to grow the food on moon itself, then the problem of carrying all the food is solved. The astronauts can actually grow their vegetables on the surface of the moon and actually convert that into edible items, whatever they want, like French fries or whatever they want. So it's research going on. Already China Space Agency has grown a cotton plant way back in 2019 on the surface of the moon as part of an experiment. And very soon in Artemis 2 or 3, there is a very clear focus of growing potatoes on the surface of the moon in the lunar regolith, which is the lunar soil. So we will wait for those missions, because that is the critical part. If we have food, we have atmosphere, we have water, we have fuel. The fifth most critical part is the building structure, because there is no atmosphere naturally found on the surface of the moon. So astronauts will have to live either deep inside the lava tubes, but lava tubes are quite unstable as we have seen them on the Earth. Sometimes the lava tubes can collapse. So we do not know how strong the lava tubes may be, but lava tubes which is deep inside natural holes could be a viable places where the lunar bases can be built inside the lunar areas. However, we would still need a lot of building material. We would need roads, we would need landing pad, launching pads, runways, and if there are two distinct places, then we need to connect them by way of creating some sort of a transport layer like a train or things like that. So all of these we would need a lot of material on this surface. So the regolith is a very powdery substance. It's a well grounded substance, that's what we have found. And also our space suits will be of different kind, because the microscopic properties of the regolith is such that it's very sharp. It's like made of silica, which is sharp. So if we do not have a proper protection, the regolith can cut our space suits or the moon suits which the astronauts will wear. However, if we have overcome these small teething problems, then we can start looking at building structure. So for building this structure like highways, roads, railroads and building, the regolith is a very fine material. All we need to do is mix it with certain things or carry out certain chemical chemical mixing with different substance, and then we can create building structures. So we don't have to carry all the cement to convert that cement into concrete. We can actually use the regolith, mix it with certain portion of different substance, and then regolith is a very fine, very good building material. Using this regolith, we can actually construct our buildings, domes, to carry out various work preparation. We can actually store our vehicles, which are moon vehicles. We can also create a warehouse where we can start keeping the spare parts, and we can also create habitats. We can also use regolith to build roads and network on the surface of the moon, which would be very, very important for future settlement. If there are no transport possible, then it will be difficult to do any mining or any viable commercial activity on the surface of the moon. So scientists now say that using the 3D printer technology, which is advancing, we can actually send the 3D printers, and 3D printer will be autonomous completely. They will actually use the regolith, process it, and then lay down a road network, and they keep working. They keep working without any monitoring. So if you send these robotic probes, they can start building various constructions of various buildings, and they can also start constructing road network, which will be very, very useful for future moon travelers. Because on the surface of the moon, at least humans can live for continuous habitation for 6 months before returning to Earth and then spending some time on Earth and go back again. So a lot of these machines, AIs, robots will help the creation of the base on the lunar surface by using the local material which is available, which is like a dirt. It's like available everywhere, and all we need is the technology and well thought out plan, and use the material which is found on the surface to extract titanium for building equipment and rockets and vehicles directly on the surface of the moon. And we can take that titanium out directly from the dirt or the soil or regolith, whatever you want to call it. It's available everywhere. Material is available everywhere. All we need is a clear roadmap, a test of technology, and using the regolith, we can also extract oxygen, water, and hydrogen as fuel. So I think a lot of research is going on in this area, because that is the basic. Before we start sending humans out there, we need to set up the whole base infrastructure, and using the normal dirt, moon dirt, we can do that. And we can send these robotic probes, and who will actually start working on some sort of a blueprint and keep working without any monitoring, and they will create infrastructure, road, etc., prepare the colony, and then humans will only go retrofit the colony for their own environment. Maybe there will be quarters for experimentation, there will be quarter for living. All of these things can be prefabricated by the robots and 3D printer. So right now the 3D printer construction technology is coming up. There are a lot of competitive contracts being assigned by NASA and other space agencies to the private players, who can actually come up with more innovative ideas and then convert that into a viable lunar colony. So friends, this is something which is happening as we speak. If you have any thought or any comment, please feel free to send it across, and I will respond to you in the next edition of Science Show. Until then, thanks for watching, keep rocking, and be safe. Bye for now.